Hello YouTube, this is Salam. I am making a playlist on how I'm replacing the HVAC system in my house. I'm dedicating this video to share my knowledge on how to braze the HVAC system. I hope you enjoy this video. Each type of brazing material requires a specific range of temperature to be able to do the brazing correctly. In my opinion, the best material for HVAC system is to use the silver solder. I personally like the 15% because it's flow nicely. As you see, I brazed this together to do this experiment and it looked great. This just to duplicate the valve of the condenser unit, and we also could apply or flow nitrogen through this. You don't want to use any brazing material that requires a flux, because the flux, when you apply it to the tubing and then when you start applying the heat, it will turn to liquid and it will get sucked in to inside the tubing. And the HVAC system is a closed loop, so the flux will circulate inside this copper tubing, and it is acidic, so it will etch the tubing, and also if it gets mixed with the oil, it will damage the compressor in the long run. So you want to stay away from anything that requires a flux. When you braze with silver solder, you won't be able to use this type of torches. They will generate enough heat to melt the brazing material. However, when you try to braze AC tubing, you are trying to protect the valve of the condenser or the evaporator coil and the air handler by wrap it with a wet rag. So this will not be able to keep up and generate enough heat to be able to do the brazing correctly. The best method is to use oxyacetylene. It will give you plenty of temperature to heat the pipes and also to flow the silver solder. I have oxyacetylene set in my shipping container. However, at the house, I have this oxypropane setup. The second best option is to use acetylene air. It will also generate a heat close to the oxyacetylene. The oxyacetylene, it will generate heat about 6,000 degrees Fahrenheit, and this is plenty to melt the silver solder. Based on the alloy used of the silver solder, this material will melt or flow between 1100 degrees Fahrenheit to about 1500 degrees Fahrenheit. I brazed a lot of stuff using oxypropane. The oxypropane will generate about 5100 or 5100 degrees Fahrenheit of heat, and this is plenty to melt and braze using this type of brazing material. I put this setup together many years ago. I built this cart myself, and I use it to braze cast iron, or when I braze copper to steel, and I also use this setup to braze aluminum. I may show this in the future. There is many types of tips available to generate different heat range or how much heat you want to generate. If you are brazing a pipe that has nothing to do with HVAC, it's probably the best option to use a rosebud. It will generate the heat very quick and you will be able to melt the material, and the material or the brazing material will flow nicely and braze everything in that joint, and it will go all the way to the inside. And I will show you a few pieces I cut after this, this section when I braze. But personally, I like to use this tip because I could generate the heat to the area that I want to braze. This over here is number 2 tip. I modified it by drill it with a 1/16 of inch drill bit, and it will generate enough flame to do the brazing for silver solder or for this bronze brazing rods. I like to set my oxygen to about 20 and the propane to 10. I have some of these copper fitting they design for water lines or copper water lines. I'm not going to use them. What I did, I cut these pieces out of the new AC line that I bought. It's 7/8 in diameter. I cut them to 2 inches in length, and I'm going to do the brazing with them. I have the swaging tools. However, these will generate heat. And as you see, this piece, when I swage it, it already built the cupric or copper oxide, and I had to hit it with the wire brush. These two pieces, they will simulate the AC system. Basically, I removed the valve over here, and this is what you should do when you braze, AC system, to relieve any pressure. And I drilled a hole over here the same size as this one. So when I flow nitrogen, the nitrogen has a place to escape. I'm also going to braze one without nitrogen, and this will simulate the AC system. So it will restrict the airflow. Because if I just braze one with nitrogen and then I braze another one just open like this, this will not be a fair experiment. So I'm not going to use this swaging tool. What I did, I took this piece of steel and I machined it on the lathe, and I'm going to swage two pieces with it. Basically, turn it down to 7/8 in diameter, and the length of the straight part over here is 7/8. I'm going to deburr this piece, and you need to make sure to deburr all the joint and make sure they clean. The silver solder, it doesn't require all this extra work. However, it's better to do a good job. And the burr actually will cause restriction. It will make the pipe smaller. It won't allow, all the bath of the pipe or the ID of the pipe. So make sure to clean it. And it's a good idea to practice with the brazing before you do any type of work on the HVAC system. Because if you set the temperature too high, it will melt the copper tubing or the valve, and you ruin, a very expensive piece of equipment. And I highly recommend, if you don't have any background about brazing electricity, don't do this kind of work. Just view this video for entertainment only, because this could be dangerous on you, and it also could damage your equipment. I'll probably speed up a few footage of this video. However, all the brazing that I'm going to do, I'm not going to speed it. This way you could see how long it should take. I am going to use this nitrogen brazing regulator to do the brazing. It's very small and simple design. The way it works, they have the frame and they have this dial. And they use O-ring and whatever to prevent any nitrogen leak. And the way it works, it has 3 positions. Off. And when you put it on the off position, it will block and prevent nitrogen from going this way. And when you go to purge, on this position, there's a bigger hole to allow the nitrogen to flow through this regulator. And then if I put it on braze, it has very small hole. I could see through it. If you set your nitrogen regulator to 50 psi, this will restrict the flow when it's on braze to about 3 to 6 CFH or cubic feet per hour. This amount of nitrogen is plenty to push the oxygen away from the lines and prevent oxidation. And also, it's not too much where it's bother you and try to push the melting brazing material away from the joint. I will get the camera and try to show you this small tubes inside this regulator. They did put or etch a flow direction on this regulator. However, I don't think it's matter, but you know, it's supposed to be connected to the regulator, so it has to be connected like this. And then the hose will go to the system. Now it's on a braze. On purge. And on off, it will block it. I set this to about 50. You could increase it from here. And this is on purge. And this is on braze. I want to show you something about brazing a pre-charged unit. This is the original or the old valves that I removed from the condensing unit, the old one. And as you see, when they brazed it 30 years ago, the brazing material only went about 1/8 to 1/4 inch. That's because you have to have in consideration, you have to wrap this with a wet rag. The wet rag will prevent the temperature of this part to exceed 100 degrees Celsius, because that's the boiling point of water. The copper is very good thermal conductor. However, it will be fighting the heat from your torch and the cold area over here. You don't want to overheat the valve because this may cause explosion. So you need to find a very sweet point where you could get this to temperature so you could flow your brazing rod, and at the same time you keep this one cold so you don't damage this valve. Same thing with this liquid line. I could only see the brazing material at the edge. However, it did great. This system been in operation for 30 years. I have these two set up, ready to be brazed. They both clean. I'm going to use nitrogen on one of them and the other one I won't. Like I said, this to simulate the valve on the condenser unit. And I'm going to wrap it with a wet rag. My condenser, it's pre-charged. And the valve, it has warning. It say don't exceed 250 degrees Fahrenheit. So I want to make sure to not apply too much flame and overheat that valve, because this may lead to explosion. Especially the R32 is flammable. The R22 and R12, the one I dealt with in the past, they are not flammable. However, they are bad for the environment. That's why the government regulate for this manufacturer to use R32. So I'm going to protect this area with a wet rag. And this over here to simulate the system restriction. And also the nitrogen will flow through this hole, and this will fill this tube with nitrogen. As I showed earlier, the old system, when they brazed it, they only brazed about 1/8 inch to a 1/4 inch, not even a 1/4 inch. And this was strong enough, even though they didn't fit it correctly. The pipe was set like this, and they brazed it together. They didn't even fit it all the way. Watch the video, the intro of this playlist, if you are interested to see how that was connected. And it did great. It's held together, you know, for about 29 to 30 years. It didn't leak. So the idea, we don't want to overheat and damage the equipment. Because if you blow up the valve, then this will leak all the freon, and then it will damage the valve. And then probably you have to change the complete condensing unit, and we don't want to do that. The idea behind a wet rag, the water will boil at 100 degrees Celsius. It's a little bit over 200 degrees Fahrenheit. So this will prevent the valve from overheating beyond the 100 degrees Celsius. When I run the torch, it's going to be loud. You need to make sure to heat the pipe first, and then move the heat to the valve when the brazing material starts to melt. And don't concentrate on one area, because this will drill a hole or cut the pipe. We just want to heat it to a little bit above 1500 degrees Fahrenheit. Let me open the nitrogen. The nitrogen is flowing. Once it's brazed like this, then crown it. It may look ugly, however, this will add to the strength of the weld. And it's okay if it's a drip from underneath. Don't attempt to quench it until everything turns to the same color. I will keep the nitrogen flowing. The nitrogen flow will also cool the pipe internally because it's cold gas running through it, and the nitrogen is not flammable, and like I said, it will push the oxygen to prevent the oxidation process. Be careful when you quench it. Don't let the steam get you. And don't stop the nitrogen until the pipe cools down. And as you see, this area wasn't affected by the heat, still shiny. I don't want to put too much water because it's not completely simulating the AC system. The AC system, once we braze this, everything is a closed circuit, so water will not get inside. However, on the AC or HVAC, when you braze, you could just dump water after you finish. I want to simulate the best of my ability the brazing of HVAC system. Okay, now I'm shutting the nitrogen. And look, the inside is still shiny. Let me cut this tube and show you how it looks like inside. But before, look at the braze. It looks good. It's not affected inside. The brazing material didn't make it all the way in because of the wet rag and also because of the nitrogen. But I'm going to straight this with a hammer, and then I will put it on the vise like this, and I'll hit it with the hammer and see how much brazing or how far it's got. And this silver solder is very ductile. It's not going to break. It's not brittle. Okay, I'm going to put it on the vise at this edge. You see, at this edge, and then I will try to bend it and see how much or how far the brazing material went. You see, if I apply a little bit more heat, it went in almost 3/4 of an inch. You could see it seeped all the way to this part. Yeah, it's very strong joint. Now I will do one without nitrogen. I brazed many systems back in the late 80s, early 90s without nitrogen. However, the old equipment, it has more tolerance. The new equipment, it's more efficient, so everything is so tight. That's why we need to make sure we don't put any or introduce any contaminant into the system. Also, nitrogen used to be very expensive and hard to come by, and it's heavy. You have to carry, too much equipment when you do HVAC, so nobody really use it. And even these days, a lot of contractors, they don't use nitrogen. Just get the flame to where it start, showing some carbon. And then open the oxygen. Right there. And now I'm start adding the crown. Same thing, we have to wait until everything look the same. And same thing, as you see, having the wet rag prevented this area from overheating. You see all this cupric oxide? This will cause problems. The way the HVAC system works, if you don't know, the compressor, it's rated for a specific type of restriction. They call that restriction orifice, piston, expansion valve, capillary tube. They use this type of tube in the refrigerator or freezers, and they have TXV. This compressor is rated to pressurize the Freon and push it through that hole. You know, that has to be, or this type of hole has to match the compressor. The compressor will build the pressure in the condenser coil or radiator, and then the fan will blow air and this will cool it down. And the Freon, actually any gas, if you pressurize it to specific type of pressure and cool it, it will turn to liquid. So it will go up through the liquid line into the orifice, capillary tube, expansion valve, TXV, and then once reach that point, when it come out, it will try to go back to be gas again. To be gas, it's required expansion, and also it requires heat. So it will evaporate. That's why they call the evaporator coil, the one in the air handler, Once the gas come out or the liquid come out, it try to go back to gas again. It will absorb the heat from the air, and that's what cools the air. And this will circulate back to the compressor, and the cycle continue. So this type of contaminant may block the orifice or capillary tube, because you're gonna do this brazing at least 4 times. You have to do it twice at the condenser and twice at the air handler. Sometimes if you run long lines, you have to do it, more times. And this will build up, and this will block that restriction, whatever the design call for. Also, this contaminant, it's abrasive. If it's get into the compressor and mix with its oil, it will be grinding it, like sand material or sand in the oil. Back in the days, what they did, they installed filters to absorb this material. However, nowadays, if you install filters, you're going to lose some of the efficiency of the HVAC system. And my system, the new one, it already has a filter and a dryer built into the condenser. And we really don't need to do that. A nitrogen will take care of it. Let me open this one and show you how it looks like inside. And as you see, as I'm doing it, more stuff falling down. Yeah, you see this oxidation? Let's try to do the same thing. Yeah, about same result. We have about, I would say, 11/16 to 3/4. Now without wet rag, we will be able to flow the brazing material all the way in. However, this, it's not something we should do, because we will damage the valve and this will leak the gas that's in it. So we're not gonna do that. But if you are interested into more brazing for non-HVAC system, I posted a video a while back about brazing the air cooler and dryer for my compressor, to use it for painting and plasma cutting and all that. I will link to it at the end of this video. Now I'm gonna go ahead, purge the AC lines with nitrogen, and then I will braze them at the condenser unit and at the air handler or the evaporator coil while flowing nitrogen through the system. Now I'm ready to cut the ends of the evaporator coil to connect my new lines. I will start by discharging the nitrogen. This unit can be recharged from the factory with nitrogen to prevent contamination, and they charge it via this valve over here. I cleaned and deburred and I cut the ends. I inserted them as far as I could. And now I'm ready to go down to the condensing unit. Make sure everything clean and connect both ends. Then I flow nitrogen and braze everything. The camera was in the way and I missed the spot. I had to go back and finish brazing this part. I will keep flowing nitrogen and I will go braze the inside. This brazing job came out great. Please watch the video titled charging and testing the new HVAC system of this playlist to see how I tested these joints for leak. Please like, share and subscribe as this will help my channel. Thank you for watching, be safe and have a great day.